Leetcode 980, Unique Paths 3. You walk from start to end on a small grid with obstacles, but every empty square must be visited exactly once. Example 1 has two such paths. Example 2, same rules, and this grid has no obstacle. There are 4 valid paths from start to finish, each one visits every free cell exactly once and ends on the goal. Example 3, 2 by 2 with start and end in opposite corners. You cannot visit every free square exactly once and still end on the goal, so the answer is 0. In many grid path problems, reaching the finish is enough. Here you need a Hamiltonian path, visit every walkable square exactly once, only 4-way steps, no revisits, and your last new cell must be the finish. Step onto the finish while anything is still unvisited, and that walk is invalid. Every move marks where you were as visited, like burning the bridge behind you. The next step cannot re-enter that square. Watch the robot leave start, lock that cell, then try to return and get blocked. You can corner yourself, the only forward neighbor is the finish, but empty squares are still uncovered. That is a dead end. Depth-first search with backtracking unwinds the last choice, unmarks the cell, and explores the next direction until every branch is tried. With the center blocked, this corner-to-corner puzzle has no complete tour. We open that cell so you can see a real success. Each new visit ticks the remaining countdown, and it reaches 0 exactly as you step on the finish. Then the full route is one valid answer. The problem scene counts every such route. Before the first move, count every non-obstacle cell, that is how many squares must be entered in total. After you stand on start, the recursive counter is 1 less, 11 on this 3x4 board. You only win when you land on the finish and that remaining value is exactly 0. Each forward step does 2 things, mark where you were as visited so you never loop, and subtract 1 from the remaining tally. That is the enter phase of depth-first search before any backtrack. Keep exploring. If every neighbor is blocked, already visited, or the finish, but remaining is not 0, then moving on to the finish would break the rule. This branch is a dead end and we abandon it. Backtracking is not a single undo, you walk the robot backward along the prefix, 1 square at a time. Each step clears visited on the cell you leave, it ungrays back to empty or start color, and you add 1 back to remaining. Here we rewind several steps until the board matches the state before that dead end, then you can try another neighbor from the earlier fork. When remaining hits 0 exactly as you enter the finish, record 1 valid path. The real algorithm backtracks and keeps searching. This board has 4 such paths in total. Here we only tick the counter to 1 for the clip. -1 squares are never entered and are not part of the walkable tally. Everything else, remaining counter, visited flags, dead ends, and backtracking, is unchanged. On this tiny board with 1 block, there is exactly 1 route that visits every open cell once and finishes on the goal. N is m times n, the number of cells. T is how many walkable squares you must visit. Time is worst-case exponential in n. Depth-first search can branch in up to 4 directions each step, and the number of partial states grows fast. The problem caps n at 20, so this brute force search is still acceptable. Space is order m times n for the visited bitmap and the recursion stack, which is at most order n deep along 1 path. Pseudocode for Unique Paths 3, count walkable cells and find start and end, then depth-first search from the start with a remaining counter. When you reach the finish, count only if the counter is 0. Backtracking clears visited after each recursive call. To do is how many squares must be entered in total. Locate the start and goal coordinates. Accumulator for paths that finish the full visit rule. Visited mirrors the grid shape. Inner DFS explores the state space. Base case, stepped onto the finish cell. A full tour only counts when rem is 0. Stop processing this branch. Try each neighbor in 4 directions. Move only onto unvisited, non-blocked cells. Mark before the recursive call. Recurse with one fewer cell left to visit. Backtrack, undo the mark for other branches. Seed visited from the start. Initial call, remaining is to do -1 because start is already occupied. Return the total count of valid paths.